Today's lesson is about permutation. All right, so let's go ahead. Basic definition. A permutation is the ordered arrangement of R objects chosen from n different objects, and no object can be repeated. So I highlighted the ordered, the R and N. Now, ordered arrangements, that means that order matters in permutation. So if you have A, B as two different objects, that's different. That's not the same as BA. Let's say two books you have. One book is called A, the other one is B. If you have the first one, A, that's different than if you have the first one, the B book. Okay. So, for example, in terms of numbers, I can do 1 and 2. This first one, number 1, is showing up as your first number because if you read that, that's 12. But if I switch 2 and 1, 2 comes first. This number is now different than this one. That's what permutation is. It's a number of arrangements that you have, but order matters. All right, let's do a quick review because we've gone through the fundamental counting principle. So we're going to use kind of the same idea. We're going to derive the formula in an easy way. So example that I put in here, how many different 3-digit numbers can be made using the digits in 1, 2, 3, 4? All right, so let's go through that. Well, there are about 4 options we have. So the first, there are 3 digits that we want to, a number with the 3 digits we can find. Well, for the first digit, we have 4 options. That's 4. The second digit for the 3-digit number, we have 3 options because we just used one of the 4, so now we got 3 left. And then the third option for our 3-digit number, we got 2 options left. Okay, that's basically it. And then of course you multiply them. Okay, simple as that. Now you could have said you multiply by 1 and that will end up being 4 factorial, and you would be right, but there's no point of putting 1 in there. That's not going to make a difference. Now, here is the manipulation of this thing. If I could have written this as 4 factorial over 1 and include the 3 and include the 4 digits here, well, I can rewrite this as 4 factorial over, and I want to get 1, so I can do 4 minus 3 factorial, which will end up giving me 1, by the way, right? And that would also give me 4 factorial, okay? Now, what was 3? 3 was R and 4 was N. Okay, so I can rewrite this as N factorial over N minus R factorial. This is actually the definition of permutation. And the way you write it is actually, it looks like this, NPR, like that. And of course, they have another notation. You can write it as NR in a bracket with a P in front of it. That's another way of writing it. Okay, so all of these are the same. And this is actually the formula for the permutation, given the fact that this permutation that you're seeing, there is no repetition as well. So no objects can be repeated. There is a slight different thing that you have to do if the object is repeated, and we're going to go through that as well, but not now. Let's do another example. So this example is exactly pretty much the same as the top example, but instead of having how many different 3-digit numbers out of the 4 numbers that we have, I made a 4-digit number can be made using all the digits. I should say all the digits here so that it makes sense in 1, 2, 3, 4. And let's see what we can do. And then maybe we can come up with a formula again, which matches this one. Okay. So again, 4. So we have 1, 2, 3, 4-digit number. The first option, we have 4 option there, 3 option for the second digit, 2 option for the third, and 1 is the last digit. Okay, so 1 option we have left. Okay, so that's 4 times 3 times 2 times 1. Very good. Now this is 4 factorial. Oh, so what happened? This gives me 4 factorial. This also gave me 4 factorial. So what's the difference? So basically, there's a 4 factorial way to get 3-digit numbers out of the 4 digits and the same number of arrangements for the 4 digits. Well, it is true. Why it is true? Remember one basic definition of the 0 factorial we said by convention that is equal to 1. Okay, so I could actually have, so this could be 4 factorial over 0 factorial, which is equal to 4 factorial equals to, so let's go ahead, 4 factorial over, and that is 4 minus 4, because I am choosing 4 objects out of the total of 4 objects, so that would be 4 minus 4, and I put a factorial in front, and sure enough, I get 4 factorial over 0 factorial, which is equal to 4 factorial. All right, so this is solution to this question, but it turns out that in this question, both answers are the same regardless of you get a 4-digit numbers out of the 4 or a 3-digit numbers out of the 4 digits that you have. All right, let's do another one. All right, look at this question. How many ways can a chairman, vice chairman, treasurer be selected from a class of 20 university students? All right, so let's write up what we do know. N, so N is equal to 20, R is equal to 3, because we have chairman, vice chairman, and treasurer. That's all we have. All right, so we can go ahead, we can say 20 P3 equals to, and then from this point on, you say 20 factorial over 20 minus 3 factorial. Okay, and this would be 20 factorial over 17 factorial. That's 20 times 19 times 18, because 17 factorial after that they divide, and then you can go ahead and find the answer to this, which will be 6,840 ways. All right, so this is another one. Last question. How many ways can 4 books be arranged on a bookshelf if taken from a pile of 7 books? All right, so we have n is equal to 7. We have R, number of objects taken from the 7 books, that's 4. And then we're going to go ahead and 7 permute 4, that's equal to 7 factorial over 7 minus 4 factorial, which will be 7 factorial over 3 factorial. Now you can use the math and the calculator, find out what that is, and that's basically the final answer. The last thing I want to talk about or share is that you have in your there are calculators that there is a functionality for factorial, and it shows up in the either in the X factorial button like that, or actually just the factorial button like that. So every calculator is different. You make sure that you can find it if you're allowed to use a calculator. Definitely every mobile phone will have a factorial button in their calculator app in there, so you can use that as well to make it faster, and you don't have to expand it all the time. And that's the usage for the calculator portion. All right, check out the next video about the second part of permutation. Okay, until next time.